So starting on the top, sine of 20 equals 8. All that's asking you to do is punch in the calculator sine of 20, which is going to give you what? 0.34. Okay. Tangent of 20 equals b. Again, that's just asking you to punch in tangent of 20, which is?
I went down the list the other way.
Okay. So we'll punch in tangent of 20. 0.364 will go. Secant of 20. To find that, now remember, you're going to do the cosine of 20, hit equals, and then use that reciprocal key, which is going to give you what? 0.939? Something's off there. Secant, remember, always has to be bigger than 1, right? 1.06 sounds better. So you do cosine of 20, then reciprocal. You did the cosine of 20, you didn't do the reciprocal key, Josh. So yep, 1.06. It happens. It's hard to remember. Cotangent of 20, what are we going to do there? Go off the tangent of 20, hit equals, and then the reciprocal, which gives us 2 point something.
2.92, 2.74, 2.72.
Okay. Let's double check it. Since we got,
No, it's 2.74.
it is 2.74? Okay.
I got it written down in a list. So I got
Technically, it would be 2.75. Because it's 2.747. But yeah, you had the right idea. Cosine of 20? Well, you're just typing cosine of 20, which is going to be what? 0.939.
You sure about this?
Cosecant. You're going to find the sine of 20, then you're going to hit equals, and then the x negative 1 gives you 2.92.
You have to find it in my list.
Sure. No.
No, I got it written down in a list, but it's just not like the list up there.
How many of you got to these down here? Need a little more time? I'll give you a couple more minutes, and I'm going to add 2 more down here because I ran out of space. So try those 6 and see if you can remember how to find the inverse. Okay, so the difference between these here is up top here, you were given the angle and you wanted to find the value of the function. So you're given the angle here with the function, and you had to just put it in the calculator and find that value. Down here, we're missing the angle, and what we're given the value of the function. So we're trying to find the angle. And when we're trying to find the angle, that means we're using inverse functions. So for the sine of A, of course, it's going to be second or shift sine, and then the 0.32. What angle do you come up with? 18.66 degrees. And the same over here. Cosine of B equals the 0.714. We're going to do this second or shift cosine of 0.714. And what do we get for an angle? 44 point what? 44.44. Okay. Tangent of the angle equals 2.7, so we're going to do the inverse tangent. So it's second tangent of 2.7. What do we get? 6968. So 69.68. Now secant, here again, we're getting into those functions that are not on the calculator. So to calculate that, to do the inverse, we're going to do the inverse cosine. So it's second cosine. And then inside the parentheses, we're going to type in the 5.32. We're going to hit the x negative 1 before we close the parentheses. What'd you get? 79.16? Okay. Yep, 79.17 technically, but yes. Degrees. Cosecant, we're going to use the sine. So again, it's that second sine, and then 3.1, and we're going to do the x negative 1 inside those parentheses. What do we get? 10.81?
18.82.
18.82? Let's take a look. Second sine
18.819.
200.
We do thousands.
18.82, 18.819, either way. The angles we've been going to just 2 decimal places. I think in the homework I asked you to go to 5 decimal places for some of the angles, didn't it? Then for cotangent, of course, we're doing tangent. Second tangent, 0.93. What do we get? 47.08. Okay. Anybody having questions on finding those angles right now? So we can find the value of the function given the angle, or we can find the angle given the value of the function. The key is keeping it straight, which one's which, and when do you do which. And the question you always have to ask is, do I know the angle? And if you know the angle, you're just using the trig function. If you're finding the angle, that's when you have to use the inverse trig function, so the second or the shift. Now we talked about identities, and we had to use some of those identities to find these trig functions. You know, that the secant of an angle is equal to that reciprocal of the cosine. And the cosecant of an angle is equal to the reciprocal of the sine. We're just looking at trig relationships is really all we're going to do today. We mentioned briefly yesterday the tangent of an angle is equal to, because of the way the sides of the triangle work out when we do the algebra, the sine of that angle over the cosine of that angle. So let's take a look at this quickly. Let's look at the sine of 30 degrees and the cosine of 30 degrees. Well, sine of 30 degrees comes out to be 0.5. Cosine, 0.866. Now, without using the tangent button on our calculator, the tangent of 30 degrees has to be the sine over the cosine. So 0.5 over 0.866. If I divide that out, I get 0.577, it looks like. Is that the tangent of 30 degrees? And yes, it is. Well, there are several other relationships similar to this that we can do. We saw that the cotangent of an angle is equal to the adjacent side over the opposite side. Now, if you recall, the tangent of an angle was what two sides? Careful. Tangent's the one that doesn't use the hypotenuse. Opposite over adjacent. There you go. Tangent's opposite over adjacent. Cotangent was adjacent over opposite. So if we look at those two, there's a relationship there. The cotangent is just the reciprocal of the tangent. So up here, if I wanted to find the cotangent of 30, I just do 1 divided by 0.577, which is going to give us what? Give me 1.832. Well, since the tangent was sine over cosine, 1 over tangent should be the cosine divided by the sine. So for that cotangent, we could have done cosine of 0.866 divided by sine of 0.5, and that should also give us, it's not 1.8, it's 1.732, is that? 1.732. So these are what we call ratio identities and reciprocal identities. They're just trig functions that are related to each other because of the way the sides line up on the right triangle. Back to our unit circle for a second here. Let me see if I can draw something that looks sort of like a circle. That looks sort of like a circle. If I put an angle on here, let me put this angle on here right there. So that's my angle. Of course, the sine of that angle is right here. That length is the sine of the angle. The cosine of the angle, we said, is this length down here. That's the cosine of our angle. This is a right triangle. And in a right triangle, there's a relationship between the legs, in this case, the cosine and the sine, and the hypotenuse. Well, how long is this hypotenuse going to be, by the way? 1, because it's a unit circle. The radius of that circle is defined to be 1, and that hypotenuse is the radius of the circle. So that, yeah, that radius is always going to be 1. Well, we had that Pythagorean relationship, a squared plus b squared equals c squared. So for this triangle, that turns out to be the sine squared plus the cosine squared equals 1 squared. Well, what's 1 squared? 1. Now, the way they typically write this is sine squared of theta plus cosine squared of theta equals 1. Instead of using, it's, all it is saving them from having to put the parentheses in there to show that those trig functions are squared. But what this does for us is if I give you that the sine of an angle is 0.6, I can now find all the other trig functions for that angle. Because I can find the cosine right here, because 0.6 squared plus the cosine of that angle squared has to equal 1. So I can find 0.6 squared, which is 0.36. We can come back and trying to solve now for the cosine. Subtract the 0.36. Cosine squared of that angle is 0.64. And now we just have to square root. So square root, the cosine squared is just cosine of the angle. Square root of 0.64 is 0.8. So the sine of this angle is 0.6. The cosine from that relationship has to be 0.8. How about the tangent of this angle?
So, what's the opposite leg? Opposite leg over adjacent leg.
Remember, we can find tangent of sine over cosine as well. So 0.6 over 0.8 divides out to be 0.75. Does that make sense?
Go up one.
See this? Yeah. Tangent, this is the opposite, and this would be the adjacent.
And those are always where the sine and cosine are.
Yes. The secant of the angle, of course, is 1 over which function? Cosine. So that's 1 over 0.8, which is what, 1.25? The cosecant is 1 over sine. So that's going to be 1 over 0.6, which is going to be 1.67. And the cotangent, there's a couple of different routes we go there. We could either go 1 over the tangent, which would be 1 over 0.75, which is 1.33. Or we could have done cosine over the sine, which would be 0.8 over 0.6, which would also be 1.33. Secant is 1 over the cosine.
And tangent is
Sine over cosine. So this list right here, along with this one for cotangent. So cosecant is 1 over sine. Cotangent is either 1 over tangent or cosine over sine. So in many cases, if you know one trig function, you can find all of them. If you know 2 trig functions, you can almost always find all of them.
and then
Oh, go ahead. You good? So now we need to look at here angles that are outside of our standard. Most of these trig functions were designed to work on angles between 0 and 90 degrees. But there are other relationships that we end up with as we go around the unit circle. We had mentioned some terminology the other day where we said this 0 degree point is referred to as the initial side. That's just because that's where the angles start. And as we rotate around where that angle stops, that's referred to as the terminal side. And that defines a point on the circle. That arc there might be considered a 70-degree arc. That point might correspond to a 70-degree arc. And what that means is from that initial side to that point, it traces out a 70-degree arc, which means that this angle has to be a 70-degree angle that we're dealing with. But in reality, that angle being where that purple line is, where that terminal side is, we really don't know if it went 70 degrees or if it wrapped around once and came back that far again, or if it wrapped around 2, 3, 4 times. So that concept is what we call coterminal sides. So for that 70-degree angle, there are other angles that are coterminal to it. 430 degrees, for example, is coterminal to 70. Where did the 430 come from? Perfect. Around the whole circle is 360, plus another 70 is 430. The next one would be 790 degrees. That's around twice. Each time, of course, I could add 360 degrees. So the next one would be, what, 1150, I believe? And we keep going. There's an infinite number of angles that will have the same terminal side. All of those angles, because they end up in the same spot on that unit circle, will have the same sine, cosine, tangent. Will have the same trig function values. In fact, we're not limited to positives. We could have wrapped around the circle the opposite direction and ended up there. So coterminal to the 70, it could really be negative 290 degrees. Or a negative 650 degrees. Or again, we could keep wrapping around as many times as we want to going backwards. Each time going 360 degrees. So what we use when we're doing trig is called the simplest coterminal angle. What the simplest coterminal angle is an angle that is between 0 degrees and 360 degrees. This happens a lot when you look at like engine position sensors, because obviously that crankshaft or crankshaft position sensor, shaft position sensors and stuff like that. So obviously that shaft goes around thousands of times in a minute usually. It's traveled several degrees. All we care about is where it is in its current revolution. So we're looking at a coterminal angle. The other thing we want to look at this angle right here, 30 degrees, has a sine equal to 0.5. That is not the only angle on this circle that has a sine of 0.5. If I come over here, this point of the circle also has a sine of 0.5, doesn't it? What angle corresponds to that? Well, from the center out to that point would be there. How would we find that angle? Well, we find that angle because of this angle. What's this angle have to be? 30. So that would be a straight line, so 180 minus 30 is going to give us 150 degrees there. The 30-degree angles here, I don't know why that messed up like that. 30-degree angles are what are called reference angles. Remember, we called that diameter, that horizontal diameter across here, a reference diameter. And the reference angle is simply the angle between the terminal side of that angle and that reference diameter. And angles that have the same reference angle have related trig functions. So since 30 degrees and 150 degrees both have a 30-degree reference angle, they both have trig functions of 0.5. Now there are two other angles on this unit circle that have 30-degree reference angles. Now notice I didn't say that their trig functions were equal, I said their trig functions were related. These are definitely not equal. This being a 30-degree reference angle here and a 30-degree reference angle here, what's this angle here going to be, wrapping all the way around to there? Well, this is 180 here, plus another 30 would make this 210, right? This other one here wrapping around, 360 would be all the way minus 30, so this is at 330 degrees. They have related trig functions, but not equal. This sine here is not 0.5, it is negative 0.5. And the same over here. This sine is a negative 0.5. In fact, you can test it on your calculator. You know, sine of 30 we found before to be 0.5. Sine of 150 better be 0.5, and it is. Sine of 210 should be negative 0.5. And sine of 330 should be negative 0.5. Why is this a concern? Well, because when you do an inverse trig function, if I give you that the sine of angle A is 0.5, you're going to punch that in the calculator. You're going to do second sine, so inverse sine of 0.5, and your calculator is going to spit out 30 degrees. Problem is, it's not just 30 degrees. It could be 30 degrees, or it could be 150 degrees. The only way we can know which one it is if we have a picture. Obviously, if we're dealing with a triangle that looks like this, and this is the angle we're finding, which one do we really want? We want the 150 degrees. So you have to be aware of that. When we're dealing with an inverse sine, there are always two possible angles, and they are supplements. If you don't have a picture, there should be some information in the problem that indicates it's either an acute or obtuse angle. Obviously, the 150 is an obtuse angle, the 30 is an acute angle. If not, list the smallest one. So just list the 30. For cosine, there is a similar effect. It's just for cosine, it's not quite as relevant. So we have this angle here, that's our 70 degrees again. Trace this down, that's our sine there. The cosine is this length right here. The angle that has the exact same cosine is this one. That would have a 70-degree reference angle here, which would make that wrapping around 360 minus 70, or 290 degrees. So 70 degrees and 290 have the same. So the ones that have the same cosine are theta and 360 minus theta. So you can see that's not as relevant, because you're never going to have a triangle that has a 290-degree angle in it. So there's no way you can ever be looking at a triangle and saying, okay, the cosine is this. The inverse cosine, was it 70 or is it 290? Oh, no, it's never going to be. You can't have an angle in a triangle over 180 degrees. So the cosine isn't as relevant. But that inverse sine is, because the fact that it is possible, since both of those possible values of the inverse cosine could be in a triangle. This is going to be very important next week when we start looking at what's called oblique triangles. They're triangles without any right angles in them. And we're going to do law of sines and law of cosines, where we're actually solving a lot of equations where we have to find the inverse cosine or inverse sine. We have to be aware that for inverse sine, there's always two possibilities. For now, in your packet, page 345 to 347, you're going to be working on those trig functions and the cofunctions and some of those relationships and identities. Let me look at what problems they were. I didn't have that written down here. Looks like it's 1 through 51. I'll just do the odd. Now, some of them, what they're asking you to do is they're asking you to compare. Like the sine of 13 degrees to the cosine of 83 degrees. So what they want you to do is they want you to reason out. Look at this picture. First of all, cosine of 83 degrees would be the same as the sine of the complement, 7 degrees. Does that make sense? So what I'm really comparing here is the sine of 13 degrees to the sine of 7 degrees. As the angle gets bigger, does the sine get bigger or smaller? As the angle gets bigger, the sine gets bigger, because the sine is this piece right here, right? As the angle gets bigger, that goes up. If we were comparing the cosine, that would be this side. And yeah, the cosine, as the angle gets bigger, at least up to 90 degrees, the cosine does get smaller. Okay, that's what they're asking you to do, is reason it out. Use those identities to convert those into equivalent functions, and then think about the unit circle, decide which one's bigger. So it's going to require you to think about these a lot. I'm more than prepared to go over these on Monday if we have to, but I want to kind of give it to you just with those identities. I want to see if you can reason through and compare those sizes with what you know about the functions. So there you go, 1 through 51, the odds, on page 345 to 347 in your packet.
So do the first problem. Other side y compared to side r.
Okay. What that's saying is, and they're not drawing the full unit circle, which is part of what's making it confusing for you. What they're saying is if this angle here is almost 90 degrees, this is side R right here, which is always equal to 1. This is side Y here. Y is almost equal to 1. As this angle gets closer to 90 degrees, y, or the sine of the angle, is going to get closer to 1. Because if it moves up even further here, well, y is getting closer to being the radius. So as it gets close to 90 degrees, y and r get close to being equal. X, which is this value down here, as that gets closer to 90 degrees, x will become 0 at 90 degrees. So as that gets closer to 90 degrees, x gets closer to 0. It gets smaller and smaller until it disappears. So the cosine of 90 degrees is actually going to be 0.
And x and y?
Yeah.
How does side x compared to side y?
Well, x is going to get really small, and y is going to get close to 1. So x compared to y, the ratio is going to become almost 0, because x is going to become almost 0. Then for number 3 there, it's asking you to compare, and that angle's almost 0. So we're looking at it down here where it's almost 0. Well, now y is almost 0, and x is almost 1. So as this gets closer to 0, x becomes closer to being equal to r, and y becomes closer to being 0. And it's hard to put them in words, but that's really all it's asking you to see is... just as long as you can describe it is all that matters. I don't care if you actually write it in. It's just being able to see that as that angle gets closer to 0, the sine gets closer to 0, and the cosine gets close to 1. As the angle gets close to 90 degrees, the sine gets close to 1, and the cosine gets close to 0. So you'd have to write out a complete sentence, and I realize there isn't room on there for it to be written out. So as long as you can put it into words, I don't care if you actually have it written down on the paper for those.